Alright, for this first set of notes, we're going to look at different types of angles. This is actually going to be broken down into a couple different sections. The first section, or the first video that we're going to look at, and the only one that you need to watch tonight, is over just basic vocabulary with angles, terms that you need to know. And then tomorrow night, you'll look at a video for some example problems and a video on some constructions. This video is a little bit longer, but I want to get all the vocabulary in right away. So make sure that you're taking notes on these different terms and make sure you're getting some pictures down. Take this just like you would if you were in class. All right, now this first term, we'll talk about what an angle actually is and the definition of an angle. And I'm going to go through these fairly quickly just to kind of keep the video shorter. If you need to, pause the video at any point, make sure you get everything written down, and then keep going through it. Okay, so an angle, it's formed by two rays. And I'll circle a couple different words that you need to make sure that that you take definitely careful attention to. There are two rays. That's a big key right there. There are two rays. And remember, a ray just has a starting point and goes on forever in one direction. And it shares a common endpoint. That endpoint, another big term you're going to hear a lot throughout the year, is the vertex. Okay, so that point they share in common is the vertex, and the rays are the sides. Okay, so let's go ahead and look at a picture. Again, if it's going too fast, just hit the pause button and continue taking notes after you get those down. Okay, so a couple things just real quick here. This is an example of our angle. The vertex is angle A, so our vertex here is A. The sides are AM and AT. Notice they're rays, so they got the little arrow over them. And whenever we name an angle, this is how we're going to name an angle right here. We'll name it angle TAN. Okay? We name an angle with 3 points. The middle point is always the vertex. Okay? The middle letter always has to be the vertex. The other two letters are points off of the ray. I could also name this angle MAT. Okay? I can also name an angle MAT. Another way I can name it, I could also say that this is angle A. That doesn't always work all the time. There's only one possible angle that we could have, and that's this one right here. So I could say it's just angle A because A is the vertex. If I drew some other lines off of here and there could be 4 or 5 possible angle A's, then we wouldn't use this way. But it is a way that we can name it. Now we'll talk about what an angle measure actually is. Whenever we talk about the measure of an angle, it's the smallest amount of rotation about the vertex from one ray to the other ray. And we measure that in degrees. So for example, if we have this angle here, the shortest amount of rotation is from here to here. If I go around the outside this way, that's a lot longer. That's not the angle. The angle that we're actually looking at is this right here. Okay, and so this angle would measure 43 degrees. Notice the term that we use here. This is a very important thing. We use the word measure. Okay, measure lets us know in degrees. Okay? Measure is in degrees. All right, congruent angles. Congruent angles are two angles that have the same measure. Okay, congruent angles are angles whose measures are equal. So, for example, these two angles here both have 43 degrees in them, so they're the same. They're congruent angles because they have the same degree. Another way that you might see that marked is I could draw these little arcs in here. That would let you know that these two angles are congruent. It's a lot like the tick marks that we saw with segments. Another way that I could do this, and it means the exact same thing, I could draw a little tick mark here through this arc. That's another way to let you know that those two angles are congruent. Two different ways to show the same thing. All right, a protractor. All that a protractor is it's a tool that we use to measure angles. And I'll briefly show you how to measure an angle. And then obviously if you have any questions tomorrow, just let me know. We can spend some time going over those. I do have a class set of protractors that we can use, so you don't have to worry about bringing one to and from class. I would keep one at home in case you happen to not finish a homework assignment in class, but otherwise I've got a class set. All right, so let's use a protractor here. So anytime I use a protractor, you're going to see two things on a protractor. It's going to have two sets of numbers. So numbers on the inside, numbers on the outside. One goes from 0 to 180, the other one goes from 180 to 0. That just allows you to measure two different angles, okay, depending on how they open up. So if I wanted to measure angle CED, I would want to use the inside set because it starts at 0 and goes up. If I wanted to measure this angle, AEB, I would want to use this set of numbers because it starts at 0 and goes up. So that's kind of how you're looking at measuring angles. And we'll practice with this in class as well. Alright, so anytime I use a compass, I want to look for something in the middle. There should be something that lines it up. Some compasses will have a hole in the middle. Other ones will have this little crosshair looking thing right here, and that's what's going to go on the vertex. So I'm going to put that on my vertex. And now I'm going to go ahead and measure my angle. So if I want to measure angle AEB, I'm going to use this right here. I'll look at A, go to E, all the way up to B, and it shows me here that it's a 90-degree angle. So this angle right here is 90 degrees. Okay. Now let's measure this one. This one's kind of an easy one to measure here as well. So I want to measure DEC. Well, if I look, I don't want to use the outside set of numbers because it starts at 180. So I don't want to use that. But the inside starts at 0, so I want to use these numbers. So if I go from 0 to here to that ray, that would be 50 degrees. And then finally this one, I could do this one of two ways. I could leave my protractor exactly how it is, and I could subtract values. So let's say I could go from 50 to 90, so I could subtract those two. Or I can move the compass. Let's see if this will work here for me. See if it'll rotate. Maybe. Anyway, unfortunately, it doesn't look like it's going to rotate for me, so which that's fine. We can just subtract it. That's probably the easiest way to do it here. So if I'm going from 90 degrees to 50 degrees, that would make this angle 40 degrees. Now, a couple things whenever we're measuring angles, I will give you within 1 to 2, about 2 degrees of leeway. So if we were to measure angles and I were to say it was 35 degrees and you were to say it was 37 degrees or vice versa, and as long as you're within 1 or 2 degrees, I will give you credit for that. So just kind of keep that in mind. As long as you're within 1 or 2 degrees. If you're 5 or 6 degrees off, I'm not going to give you credit for it. But if I say it's 38 and you say it's 39, you're getting credit. All right, an angle bisector, again, another term that we need to know. We're going to construct an angle bisector tomorrow, in tomorrow's sets of videos, but today we'll just look at the term. So an angle bisector is a ray, big key word right there, it is a ray, that divides the angle into two congruent angles. So let me show you a picture of that. So my ray, the angle bisector, is AW. So let me circle that here. So this ray, AW, is my angle bisector. Okay, that's what it divides into two equal pieces. And so there's a way I could write that in a mathematical sense. That angle DAW is congruent to angle WAG. And if I use this little M right here, that just means measure. So that lets me know that the degrees are equal. This congruent symbol lets me know that the shapes are equal. The equals lets me know that the actual number, the degrees, is equal. And again, a way that I could show that on here, I could draw my little arc through there, and that would let me know that those two angles are congruent. Skew lines, the biggest thing you need to know with skew lines is the term. Make sure you know what the definition is here. You will see this on your test. It's a very abstract concept, so we're not going to do a whole lot with it, but you do need to know the term. It's definitely a geometrical term that we'll talk about throughout the year. We won't use it a ton, but you do need to know it. Skew lines are lines that do not intersect, so they're almost very similar to parallel, but they are non-coplanar. Okay, that's a big key word right here, is non-coplanar. And all that non-coplanar means is that they're not on the same plane. That's it. There are two lines that never touch, but are on different planes. These next couple terms, we're going to go through these very quickly. These all should be familiar. A right angle is an angle that measures 90 degrees. It has to be exactly 90 degrees. Next term is an acute angle. An acute angle measures less than 90, but greater than 0. Has to be less than 90. And then finally, the other term, you should know this one already as well, is an obtuse angle. Now here's a big difference in maybe what you were told earlier in your life, that an obtuse angle is greater than 90, but less than 180. A 180 degree angle is something completely different, and we'll talk about that here in the coming days. But an obtuse angle more than 90, less than 180. All right, just a few more terms, guys. We don't have a whole lot left. Just kind of bear with me here. All right, an adjacent angle. An example of adjacent angle is that picture that I showed you there. Okay. Let's see if I can get this all around here. Adjacent angles are angles that share a common ray. So, for example, this picture here, these two angles, and I'll put a little 1 and a little 2 inside of there. So, angle 1 and angle 2 are adjacent angles because they have this ray right here in common. No real special properties with adjacent angles. You just need to know what they're talking about because this is mathematical language that we'll use throughout the year. Now, these next couple terms, again, these should be review for you. Complementary angles, notice that they add up to 90 degrees, and that's all that complementary angles are. Angles whose sum of their measures is 90 degrees. That's it. That's all you got to it there. Okay. The next term is supplementary angles, and supplementary angles are angles that measure 180 degrees. That's all that you have there. That's 180. And think of it in alphabetical order. C comes before S, so complementary is 90, supplementary is 180. All right, we got 2 more terms. These are ones that you have not seen before, or at least you shouldn't have. These are brand new things, so make sure you get some good notes on these. Vertical angles. If we look at our pairs of vertical angles, so for example, a pair of vertical angles in this first picture would be these 2 angles right there. 3 and 4 are vertical angles. There's another pair. Let me get a different color. Angles 1 and 2 are also vertical angles. In this second picture here, these 2 angles are vertical angles, and these 2 angles here are vertical angles. And then examples that are not, notice 1 and 2, these are right next to each other, they're not vertical. 3 and 4, they're not across. We got too many lines going on here. A couple of examples that are not, 5 and 6, you got a kind of a broken line here. Notice here, they both should be straight lines. And these, they don't touch. So what a vertical angle is vertical angles are angles. Let me get this up here in the spot where we can read it. They're angles, not angles, sorry. Angles that share a vertex but have no other points in common. And I'm going to put one more word in here just to kind of solidify this definition. Are congruent angles that share a vertex but have no other points in common. Okay, so that's a really good definition of what vertical angles are. Okay, they're congruent angles. They share a vertex, but they don't have any other points in common. Okay. Next term that we'll talk about is a linear pair of angles. And a linear pair of angles, some examples of these would be angle 1 and angle 3. Those are a linear pair of angles. Angle 2 and 4 are a linear pair of angles. Angles 1 and 4 are a linear pair of angles. And finally, angles 2 and 3 would be a linear pair. Notice 1 and 2 here are a linear pair. So, based on what we see there in that picture, a linear pair of angles are adjacent angles. Follow that stuff so you can see it better. They are adjacent angles. They are, let me put this term in here. They are supplementary adjacent angles. They're supplementary adjacent angles. Remember, supplementary means that they just add up to 180. So they're just a special pair of adjacent angles that happen to add up to 180. Okay? That's all a linear pair of angles are. And that's it for the last term. Make sure you have all of these in your notes, and we'll start the assignment where we go over these tomorrow.